All right, so section 1.6, day 2, continuing to solve quadratic equations. But two things we specifically have to discuss is losing or gaining a root. And this can occur when there's variables on both sides of the equation. There's variables in the denominator. So just notice we put these on here. Losing a root can happen when you divide both sides of an equation by a common factor. And you can gain a root, which is also known as an extraneous solution, which should not be new to you. You did plenty of this in Algebra 2. This could happen when you square both sides of an equation or you multiply both sides of an equation by an expression. What can you do so that you do not lose or gain a root? Make sure to check your solutions into the original equation. Okay, and that becomes important because we change the equation at times to be able to solve it. All right, so let's do these two together. So first things first, here we have a quadratic because I would have to square that. So our first method for this would be exactly that. We see a quantity squared, so let's just algebraically work on that. So on the left-hand side, I'm going to distribute the 4x. So I have 4x squared minus 4x equals 3. Here I am squaring a binomial. So if you need to, write that out as x minus 1 times x minus 1. Or let's get in the habit of what the form of that always looks like. Square the first term, double the product of the two terms, square the last term. Okay, now I'm going to distribute the 3. Now I have a quadratic, no more parentheses, nothing more to distribute. So now I'm going to set this equation equal to 0. I'm going to move everything from the right-hand side to the left-hand side. So subtracting 3x squared, adding 6x, and then subtracting 3. So now I have my equation set equal to 0, and now this quadratic sets itself up really nicely to be factored. So factors of -3 that add to +2, x plus 3 times x minus 1. Solving each of those equations, I get x equals -3 and x equals +1. Okay, perfect. You can go back, check both of those solutions into the original, and you will see that they are both true. All right, method number 2. I'm going to rewrite. So notice here that we have a common expression on both sides of the equal sign, and that common expression is x minus 1. If it's common, we can factor that expression out. The deal is, though, when you divide by a power of x, automatically set that factor equal to 0. What this will enable you to do is not lose the root, and you'll see what I mean in a minute. Okay, so these cancel. I have squared divided by x minus 1. So what am I left with? 4x equals 3 times quantity x minus 1. So I'm going to distribute that 3. Now, notice it's no longer a quadratic, so I just have to get x on one side, number on the other. So here I get x is equal to -3. That checks out with the other answer that I got. Now, if you left it like this is the case where you would lose a root. If you did not do this, if you did not set that factor equal to 0, then you're only getting the solution of -3. But we just showed on the previous example that you better get 2 answers, and both of the answers are true. So if you want to divide out the common factor, you just have to remind yourself, time you divide by a power of x, set that factor to 0, and we very simply get the same 2 solutions. All right, and then the last one. Don't freak out yet. I understand there's fractions and factoring, and we got a lot going on here. Okay, rational equations. What does it mean to be rational? Rational means written as a fraction. Okay, so we have, this would be a rational equation here. In order to clear this denominator, so the goal is to clear the denominator whenever we have a rational equation like this, we have to determine what the least common denominator is. Notice I have x minus 2, I have x plus 2 here, and if we do a real simple factoring of that, that's our difference of perfect squares. All right, what's going on here? Okay, so my least common denominator is going to be x minus 2 times x plus 2. So what's the easiest way we can clear a fraction? We clear a fraction by multiplying by the common denominator. Okay, so I'm going to take each term, and I'm going to write this out for the video's sake. Every single piece of the equation is going to get multiplied by that common denominator. X plus 2 times x minus 2. When you choose the common denominator, okay, this doesn't come out of nowhere, it's specific. Notice now that the x minus 2 from the common denominator cancels with my first fraction. So I have x plus 2 times x plus 2. On my second term, now the denominator of x plus 2 cancels with that piece from the common denominator. So now I'm adding x minus 2 times x minus 2. And now when I look at the fraction that it's set equal to, this is exactly x squared minus 4. So it cancels out the whole denominator, leaving me with exactly what's in the numerator. Okay, so doing a little bit of multiplying here, I would get x squared plus 4x plus 4, and then plus x squared minus 4x plus 4. Okay, you can take the steps to multiply those binomials, and this would equal 8 minus 4x. All right, positive 4x cancels with negative 4x, combining like terms here. It's a quadratic. I have my x squared term, so now I'm going to move the terms to the left-hand side. I'm going to add 4x, and notice when you subtract 8, they cancel each other out. I have a greatest common factor of 2x, so I take that out. I'm left with x plus 2. And now my two solutions are x is equal to 0 or x is equal to negative 2. Variables in the denominator. Make sure you check your work. So I have to check both solutions here. So when x is equal to 0, I plug back into the original equation. So wherever I see an x, I'm just going to replace it with 0. So I get negative 1 plus negative 1 equals 8 divided by negative 4 is negative 2. So is that a true statement? Absolutely. So x is equal to 0 is a solution. When I plug in negative 2, I get, for the first fraction, 0 divided by negative 4. For the second fraction, I get negative 4 divided by, this is where our issue comes in. Negative 2 plus 2 is 0. We can't divide by 0. So x equals negative 2 is an extraneous solution. Okay, mathematically it gave us an answer, but for the original problem, it doesn't work. So our only solution to that, what looks like a big long problem, would only be x is equal to 0. Okay, we'll see you in class.